Okay, question 5. Here we're told that a fair blue die has six faces, numbered 1, 1, 3, 3, 5, and 5, and we're asked to write down the probability distribution. Now, the most intuitive way of writing down a probability distribution, I think, is a table. So let's use little b for the individual values they can actually be, so 1 or 3 or 5, and then the bottom row would be probability that capital B standing for the number that lands on the blue die, little b is in the particular value that it could be. Okay. Now notice that of course they all have equal values. There's only 3 values and they've all got equal weighting. These 2 1s, 2 3s, and 2 5s. So you can either see it as 2 sixths, 2 sixths, and 2 sixths, but 2 sixths in each case simplifies down to 1/3. So they've all got the same probability of 1/3. Now the name of this distribution, which is asked for in part B, well, it's first of all it's discrete, as opposed to continuous, which you may not have studied yet, but anyway, it's discrete. It's uniform because each probability is exactly the same, so all outcomes have exactly the same probability of occurrence, so it's uniform. So discrete uniform distribution. Okay, question 5C. This is the sort of real kicker question here, tricky one. So we've been given a second distribution table, probability distribution table. This is for the red dice, which has values 2, 4, and 6, but weighted so that probability of 2 is 2/3, probability of 4 is a 6, probability of 6 is 1/6. Okay, the blue die is still as it was, with 1/3 for each possible outcomes there. So the context here is that a coin is thrown and it lands on either 2 or 5. Now after it's landed, Hwk can then choose which die she rolls to try and beat the score. Okay. Now the fact that it's after the coin has landed is really important, because if it lands on a 5, then and she's got to try and beat that score, she's got to be greater than that score. If she rolls a blue die, it's impossible for her to get a score greater than 5. Whereas at least if she throws the red die, she's got a 1/6 chance of getting a value which is greater than 5 there. So if 5, then choose red, and the probability of that particular outcome then of winning, so 5 and Hwk wins. Now on the coin is either 2 or 5, 50-50 chance of each, so probability of landing on 5 in itself is 0.5, and Hwk wins. Well, Hwk wins if she gets a 6 specifically. So that's then probability that the red equals 6. So 0.5 times by red equaling 6, which is 1/6. Okay, and that can be written as 1/12. Half times a 6 is 1/12. Okay. If it lands on a 2 this time, that's considered it's less obvious, but it's fairly clear still. So if it lands on a 2, she's got to try and beat that score. Well, here, if it was a red die she was rolling, then she had to beat 2. She couldn't get 2 itself. She'd have to get either 4 or 6, and with a combined probability there of 1/6 plus 1/6, which is 1/3. Okay. So if she rolls a 2, you get a 1/3 of a chance then of beating it by rolling a red. But with the blue, if she rolls a 2, okay, she couldn't get the 1, but she could get a 3 or a 5. Combined probability there is 2/3. So that's definitely better than the 1/3 probability we got with the red dice. So, conclusion there is if it's a 2, then choose blue. Okay, so probability of a 2, so to win then, really for Avisha, probability of a 2 on the coin, and using the blue dice up here, probability of 3 or 5 on the blue dice, so it should be blue equals 3 or 5. So probability of 2 on the coin and blue equals 3 or 5. Now, there's only 2 sides to the coin, so probability of getting a 2 is 0.5. We said the combined probability there of 3 or a 5, combined probability is 2/3.